The National Electrical Code, or NEC, provides specific guidelines for the safe installation and operation of cellular communication towers. Understanding these regulations is crucial for ensuring the safety of personnel and the integrity of the communication infrastructure. Let's explore the key aspects of these regulations, focusing on disconnects, perimeter buffer zones, and the wiring of the tower. Firstly, disconnects are essential safety components in communication tower installations. Section 810.21 of the NEC mandates a disconnecting means for communication systems at the source of power, typically located at the base of the tower. This disconnect must be readily accessible to allow for quick and safe power shutoff in case of emergencies or maintenance. Secondly, for towers exceeding 60 feet in height, Section 810.21b introduces an additional requirement. It stipulates that an additional disconnect must be positioned at a point not less than 50 feet below the lowest antenna or other supporting structure. This supplementary disconnect is commonly located near the midpoint of the tower, providing an intermediate point for isolating the electrical system. These disconnects are crucial for several reasons. In emergency situations, such as a tower collapse or electrical fault, they allow for rapid energization of the system, minimizing the risk of electrical hazard. During maintenance or repairs, disconnects provide a safe working environment by isolating specific sections of the electrical system. The readily accessible nature of these disconnects ensures that they can be quickly activated when needed. Now, let's discuss perimeter buffer zones. Section 810.53 of the NEC establishes a perimeter buffer zone around communication towers. This buffer zone serves to provide clearance in the event of a potential tower collapse, preventing damage to surrounding structures and ensuring the safety of people in the vicinity. The size of this buffer zone is determined by the height of the tower. The NEC specifies that the buffer zone must be equal to 2 times the height of the tower. For example, if a tower is 100 feet tall, the perimeter buffer zone would extend 200 feet in all directions from the base of the tower. Section 810.53b further clarifies the restrictions within this buffer zone. It prohibits the construction or placement of buildings or other structures within the perimeter buffer zone. The only exception to this rule is for structures that are necessary for the operation or maintenance of the tower itself, such as equipment shelters or access roads. The intent of this regulation is to minimize the risk of damage or injury in the event of a tower collapse. By maintaining a clear zone around the tower, the potential impact on surrounding areas is significantly reduced. Finally, let's turn to the wiring of the tower. Section 810.41 of the NEC addresses the requirements for all electrical wiring associated with communication towers. This section mandates that all wiring be installed in accordance with Article 770, which covers communication circuits. Article 770 provides detailed specifications for the types of cables that can be used, the methods of installation, and the protection of communication circuits. Section 770.110 requires that cables used for communication circuits be listed for their intended use. This means that the cables must be tested and certified by a recognized testing laboratory, such as Underwriters Laboratories or Intertek, to ensure that they meet specific safety and performance standards. The cables must also be suitably supported to prevent strain and damage. Section 770.113 specifies the minimum bending radius for communication cables. The bending radius is the smallest radius to which a cable can be bent without causing damage to the conductors or insulation. The minimum bending radius depends on the type and size of the cable. Adhering to the specified bending radius is essential for maintaining the integrity of the cable and preventing signal degradation. Section 770.139 requires that communication cables be protected from physical damage and exposure to the elements. This includes using conduit, raceways, or other approved methods to shield the cables from abrasion, impact, moisture, and ultraviolet radiation. The selection of appropriate protection methods depends on the specific environment and the type of cable being used. In summary, the NEC provides comprehensive guidelines for the safe installation and operation of cellular communication towers. These guidelines address several key aspects, including disconnects, perimeter buffer zones, and wiring requirements. Disconnects, as outlined in Section 810.21 and B, are critical safety components that allow for rapid de-energization of the system in emergencies or during maintenance. The placement and accessibility of these disconnects are carefully regulated to ensure their effectiveness. Perimeter buffer zones, as defined in Section 810.53, establish a clear area around the tower to mitigate the risk of damage or injury in the event of a tower collapse. The size of the buffer zone is directly related to the height of the tower, and restrictions are placed on the types of structures that can be located within the zone. Wiring requirements, as specified in Section 810.41 and Article 770, ensure that all electrical wiring associated with the tower is installed safely and reliably. This includes the use of listed cables, proper support, adherence to minimum bending radii, and protection from physical damage and exposure to the elements. By adhering to these NEC regulations, communication tower operators and installers can significantly reduce the risk of accidents, protect the public, and ensure the reliable operation of communication systems. It is essential to consult the latest edition of the NEC and to seek guidance from qualified electrical professionals to ensure compliance with all applicable codes and standards. Furthermore, it's important to remember that these are just some of the key NEC regulations related to cellular communication towers. Other sections of the code may also apply, depending on the specific circumstances of the installation. These could include regulations related to grounding, bonding, lightning protection, and the installation of specific types of equipment. Grounding and bonding are essential for providing a low impedance path for fault currents, reducing the risk of electrical shock and equipment damage. Lightning protection systems are designed to intercept lightning strikes and safely divert the current to ground, protecting the tower and its equipment from damage. The installation of specific types of equipment, such as antennas, amplifiers, and power supplies, may also be subject to specific NEC regulations. These regulations are designed to ensure that the equipment is installed safely and in accordance with the manufacturer's instructions. In addition to the NEC, other codes and standards may also apply to cellular communication tower installations. These could include local building codes, zoning regulations, and industry standards. Local building codes may address structural requirements for the tower, as well as requirements for access and safety. Zoning regulations may restrict the location and height of towers, as well as other aspects of their construction and operation. Industry standards, such as those developed by the Telecommunications Industry Association, may provide guidance on best practices for the design, installation, and maintenance of communication towers. It is essential to be familiar with all applicable codes and standards before beginning any work on a cellular communication tower. This includes consulting with local authorities, obtaining necessary permits, and hiring qualified professionals to perform the work. Proper planning, design, and installation are essential for ensuring the safety and reliability of cellular communication towers. By following the NEC and other applicable codes and standards, you can help to protect the public, prevent accidents, and ensure the reliable operation of communication systems. For example, let's consider a hypothetical scenario involving the installation of a new cellular communication tower. The tower is located in a rural area and is designed to provide coverage for a nearby community. The tower is 150 feet tall, and it will be used to support several antennas and other communication equipment. Before beginning the installation, the tower operator must obtain all necessary permits from local authorities. This includes submitting detailed plans for the tower's construction and operation, as well as demonstrating compliance with all applicable codes and standards. The operator must also conduct a thorough site assessment to identify any potential environmental or safety hazards. This could include assessing the soil conditions, identifying nearby wetlands or protected areas, and evaluating the risk of lightning strikes. Once the permits are obtained and the site assessment is complete, the tower operator can begin the installation process. This involves constructing the tower foundation, erecting the tower structure, installing the antennas and other equipment, and connecting the electrical wire. All work must be performed by qualified professionals in accordance with the NEC and other applicable codes and standards. This includes ensuring that the tower is properly grounded and bonded, that the antennas are securely mounted, and that all electrical wiring is installed safely and reliably. Once the installation is complete, the tower operator must conduct a final inspection to verify that all work has been performed correctly and that the tower meets all applicable safety requirements. This includes testing the grounding and bonding system, inspecting the antennas and equipment, and verifying that all electrical wiring is properly installed and protected. After the final inspection, the tower operator can begin operating the tower and providing communication services to the community. However, the operator must continue to maintain the tower in accordance with the NEC and other applicable codes and standards. This includes performing regular inspections, conducting preventative maintenance, and making any necessary repairs. By following these steps, the tower operator can ensure that the cellular communication tower is installed and operated safely and reliably, providing essential communication services to the community while protecting the public and the environment. The NEC is not static, it is updated regularly to reflect changes in technology and best practices. It is crucial to stay informed about the latest edition of the NEC and any local amendments or interpretations that may apply in your area. Continuing education and professional development are essential for electrical professionals working with communication towers. This includes attending training courses, reading industry publications, and participating in professional organizations. By staying up to date on the latest codes and standards, you can ensure that you are providing the safest and most reliable installations possible. The information presented here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional before undertaking any work on a cellular communication tower. Furthermore, it is important to note that the NEC is a minimum safety standard. In some cases, it may be necessary to exceed the requirements of the NEC to ensure the safety and reliability of a communication tower installation. This could include using higher quality materials, implementing more robust grounding and bonding systems, or providing additional protection against lightning strikes. The specific needs of each installation will vary depending on the location, the type of equipment being used, and the surrounding environment. Therefore, it is essential to conduct a thorough risk assessment and to develop a comprehensive safety plan before beginning any work on a cellular communication tower. This plan should address all potential hazards and outline the steps that will be taken to mitigate those hazards. By taking these precautions, you can help to ensure the safety of personnel, protect the public, and ensure the reliable operation of communication systems. Let's delve deeper into some specific aspects of the NEC requirements for cellular communication towers. For instance, the selection of appropriate conductors for the wiring of the tower is critical. The NEC specifies the ampacity or current carrying capacity of conductors based on their size, insulation type, and the ambient temperature. It is essential to select conductors that are adequately sized for the expected load and that are suitable for the environmental conditions. The NEC also provides guidance on the installation of conductors in raceways and conduits. Raceways and conduits are used to protect conductors from physical damage and exposure to the elements. The NEC specifies the types of raceways and conduits that are permitted for different applications, as well as the methods for supporting and securing them. Another important aspect of cellular communication tower installations is the grounding and bonding system. The NEC requires that all metal parts of the tower, including the tower structure, antennas, and equipment, be properly grounded and bonded. Grounding provides a low impedance path for fault currents, reducing the risk of electrical shock and equipment damage. Bonding connects different metal parts together to create a common ground potential, preventing voltage differences that could cause arcing or sparking. The NEC provides detailed requirements for the size and type of grounding and bonding conductors, as well as the methods for installing them. The NEC also addresses the requirements for lightning protection systems on cellular communication towers. Lightning protection systems are designed to intercept lightning strikes and safely divert the current to ground, protecting the tower and its equipment from damage. A typical lightning protection system consists of air terminals, down conductors, and a grounding electrode system. Air terminals are installed at the top of the tower to intercept lightning strikes. Down conductors are used to carry the lightning current from the air terminals to the grounding electrode system. The grounding electrode system provides a low impedance path for the lightning current to dissipate into the earth. The NEC provides detailed requirements for the design, installation, and maintenance of lightning protection systems. In addition to the technical requirements, the NEC also addresses some administrative aspects of cellular communication tower installations. For example, the NEC requires that all electrical work be performed by qualified professionals who are licensed or certified to perform such work. The NEC also requires that all electrical installations be inspected and approved by a qualified electrical inspector. These administrative requirements help to ensure that electrical work is performed safely and in compliance with the NEC.